Now let us talk about overflow detection. We have done this in terms of adder circuit, where we said that okay, last stage ripple carry full adder, last carry out indicates whether there is overflow or not. If it is 0, it is not overflow, and if it is 1, it is an overflow. Now how about the subtraction? And even the question become like, since we combined adder as subtractor, how about overflow detection for both addition and subtraction together? Okay, also keep in mind here, now we are talking of representation of values in 2's complement format. Okay, in 2's complement format. So here we need to first understand what is an overflow condition. Let's say I'm talking about an n-bit computing system, like 16-bit computing system or 64-bit computing system or 32-bit computing system, which is like both 32 and 64 are common nowadays. So for those system, if an n-bit operation like 32-bit operation or 64-bit operation results in a quantity that cannot be held within n-bit register, the condition is called an overflow. Okay, and in this context, I would say that negative, like subtraction, is also an overflow. Like if you are subtracting between two numbers and the result cannot be represented with that target number of bit, like let's just assume we are talking about 32-bit computing system. So we are subtracting between two 32-bit values, and if the result of the subtraction cannot be held within 32-bit, then it's an overflow. Some people confuses with something called underflow, and they think addition gives an overflow because it cannot hold that large amount value, and subtraction is underflow because it goes below certain value. But underflow is completely different concept, so don't get into that misconception ever. Underflow is not related to subtraction. We'll talk about that maybe later in the semester, or if you have taken like your computer science 47 class, we talked about that little bit there about the underflow condition. Okay, so overflow condition is always applied to the part when two operation, it, by the way, it may not necessarily be related to addition subtraction only. Any operation, any mathematical operation, if the result cannot be held within that number of bit, it's an overflow condition. Okay, addition, subtraction, multiplication, everything has overflow condition for that. Now two unsigned number, for two unsigned numbers, only addition can create overflow, right? Only addition can create overflow. That's first claim. And for two signed number, overflow can occur with addition if both numbers are positive or both number of negative. Okay, so first of all, we are not talking about subtraction anymore because we already modeled it as an addition. So a minus b is practically a plus of minus b. Okay, so now we are talking about the addition. If it is an unsigned, two unsigned numbers, only addition, okay, addition of two numbers signed can be cause an overflow, right? We are not even talking about subtraction here. Now when becomes a like two signed number, that's what our more interest is, then overflow can occur if both the numbers are positive or both the numbers are negative. Okay, so let's try to understand this part a little more. So we are trying to do here, like you recall this number line, right? Then I have some like this is my 0, right? And then these are all like a positive region number values, and these are all negative region values, right? So now let's say in this case, like one of my value a resides right here, okay, another resides right here in the number line. Now if I add them both, then my result will be somewhere in between them, right? Somewhere in between them. Somewhere, depending on what value, it can go either to the negative region or positive region, doesn't matter. C will be somewhat between A and B. So if I am able to represent A and B with this number of bits, I should be able to represent C as well, right? No brainer. So, but if my both A and B lies in, let's say, negative domain, and we add them, so my result would become somewhere here, right? It depends on what the value of A and B. So it will go more negative. If both the numbers are more negative, then the value becomes more negative, and it has a possibility that that value is out of range for my 2's complement representation for that many bit. Same thing happens if my both A and B lies in the same direction. Of course, in this case, B and C will become like here. So in that case, value C, it can happen. It is that large enough not to be fit into like n-bit 2's complement, like 32-bit 2's complement format for a 32-bit system. So that's also an overflow. So that's why we are claiming that for two-signed number, overflow can occur with addition if both numbers are positive or both number of negative. Okay, so this concept has to be very clear to you. Now what we can do here, so we are now consider like both two conditions, right? Both positive and both negative. All right, so both positive means your bit pattern will be something, will start with 0 MSB side and some bits, I don't know, some bits, like let's talk 8-bit, right? 1 2 3 4 5. Okay, and another would be like some bit pattern start with 0 because it is a 2's complement. Again, this is a 2's complement 8-bit patterns we are looking at. So we become like, let's say the other bit pattern is some bit pattern. It doesn't matter what the bit pattern is. Now what's my overflow condition here? In this case, if we add them, like we are adding them both, right? If we add them, my so when we can surely determine that it's an overflow. Okay, now this is bit 8. Okay, let's put the indices values there, right? 0. Okay, I need to do it from here. 7 6 5 4 3 2 1 0. This is the bit index. Okay, and then your carry out from this 7th position would always be 0, right? So we can write that C out 8, or C out from 7 equals 0 always, right? That's one thing. And I don't have an overflow if this position result is 0, and then it becomes like, right, if my addition result gives 7th or 8th bit position as 0, it's not overflow, it's a positive number, because two positive number addition gives a positive number. Now if this position is 1, then it's overflow. Okay, so now what dictate the value of at this position? So x is definitely 0 plus 0 plus your C carry out from 6, right? So x is 0 plus 0 plus 0, the sum of those bits of the zeros, right? And C carry out from the 6 is can be either so this is, let's first look at this. This is practically your C carry out 6, right? Now that means your x is carry out 6. That means if CO6 equals 0, not overflow, else overflow, right? We can make that logic. All right. Now let's talk about similar thing in terms of negative numbers. Let's copy the same here just for our discussion. So in this case, your negative, both are negative, right? So 2's complement, this position will be 1, okay? And we expect both negative addition would give a negative at this point, okay? And we know CO7 in this case will always be 1, right? It will be like 1 plus 1 plus the carry out from the other, like CO6, 6th stage. So in this case, if it is a both negative condition, your CO7 is always going to be 1, and your x is equals 1 plus 1 plus CO6. Now as a sum bit, 1 plus 1 is giving you 1 0, right? That means as a sum bit, x is kind of depending on 0 plus CO6, right? So we take the CO7 as 1 plus 1 0, that one goes to the CO7, and now your x is basically depending on CO6. Now two negative number, if it gives 0, then it's the overflow, right? Because it has to be a negative number. So if it is 1, then it is not an overflow. So that means now here also we are depending on x is practically depending on your 6, the CO6 carry out from the 6th stage. And in this case, if CO6 equals 1, not overflow, else it is overflow, right? So that's the logical deduction. Now look at, just place them in a truth table, okay? So we know for both positive, your addition CO7 is going to be 0 always, and for subtraction, like sorry, both negative addition, your CO7 is always going to be 1, right? So CO7 CO6 and my overflow, that's my output I'm trying to do there, determine there. Now for sub addition, for both positive value addition, your CO7 will be 0 always, right? And your CO6, if it is 0, not a overflow. If it is 1, it's overflow. Okay, it's not overflow, it's overflow if it is not 0. Now for two negative number addition, CO7 will be 1, and if CO6 is 0, it's an overflow, and if CO6 is 1, it's not overflow. Now look at this table. It becomes as simple as overflow is CO7 XOR CO6. So your overflow detection circuit now is as simple as an XOR between these two stage carry out, stage 6 and stage 7 for 8-bit like adder subtractor circuit. So your but the how that simple circuit came from a very deep understanding of what is going on in mathematically and conventionally of 2's complement form and logically. So we apply all our understanding into solving this problem, how to detect an overflow condition for an adder subtractor circuit where we are doing addition and subtraction assuming 2's complement format. This is how we do, like it is involved in lot of analysis into it. Okay, so going back to our lecture, your overflow detection circuit is practically very simple. Let's say it's an n-bit adder subtractor. You take the carry out from n-1 stage and carry out of the n stage, XOR them, and that becomes your overflow bit. Okay, so this is simple. So this is like simple to remember this circuit, but like it is hard to remember the explanation why we came up with this simple XOR based circuit that can detect my overflow.